So here we're asked to use transformations to sketch the graph of the function f of x equals -1 plus the square root of -x. If we're using transformations to sketch the graph, then the idea is to first draw the parent graph. So it's helpful to memorize the graphs of some basic functions, one of which is y equals the square root of x. This is what we call the parent function for the function given in this problem. So it's just the basic function with everything extra stripped away. So forget the -1 or the -1 out front. Forget the negative in front of the x. Strip it down to just bare bones, y equals the square root of x. Now, before we apply transformations, we need to get the graph of that basic function on the page. So we have something to transform. So again, this is where it helps to have the graph memorized. The graph of a square root function looks something like this. It's half of a parabola knocked on its side. It's important to plot a few points precisely. So again, we have something to transform. So the graph of y equals square root of x extends out of the origin. And you could verify that by plugging in if x equals 0, square root of 0 is equal to 0, so y equals 0. And then just plug in a couple of other convenient x values. So if x equals 1, the square root of 1 is 1, so that gives me coordinates 1, 1. I don't want to mess with square root of 2 or square root of 3, but the square root of 4, if x is 4, then y is the square root of 4, which is 2. So now we've got 3 points plotted precisely on the page. And I'm going to label this. So this is the graph of our parent function, y equals the square root of x. Now it's time to look at the equation of the given function and decide what transformations we need to apply. So here's the equation for the given function. This -1 is outside of the square root. This is outside of that parent function. Values that are added or subtracted outside of the function correspond to a vertical shift in the graph. Because this is -1 as opposed to +1, this is a vertical shift down 1 unit. The negative under the radical. So first of all, things that are applied inside of the function, so in this case under the radical, correspond to horizontal changes in the graph. So whatever's outside of that parent function corresponds to a vertical change in the graph. Whatever's inside of that parent function corresponds to a horizontal change. Now notice this isn't x minus 1. This is a -1 times x. And when you have a -1 times your function or times x inside the function, that corresponds to a reflection, as opposed to a shift down 1 or right 1. So because it's -1 times x, this is a reflection across, well, like I said, if it's inside of the function, it's a horizontal change in the graph. So a reflection this way, horizontally, which is across the y-axis. And those are the only two transformations we need to apply because those are the only extra bits that were added to the parent function to get the given function here. Now, in terms of the order that you perform these transformations in, vertical shifts should always come last. So I am going to take these points that we plotted on the graph of y equals the square root of x. I will first reflect them across the y-axis, and then I'll shift down 1. The rule of thumb is always apply vertical shifts last. So I'm going to go 1 point at a time. So take this point at 0, 0. If I reflect it across the y-axis, well, when it's sitting right on top of the y-axis, that's not going to reflect anywhere. So the reflection doesn't do anything to this particular point, but then you would shift it down 1 unit so it lands right here at 0, -1. Let me move this next point. So here's a point at 1, 1. Reflect it across the y-axis, then it's going to land here. And from there, shift down 1. So it ends up at -1, 0. last point. So this is at 4, 2. It doesn't really look like it, but it's supposed to be at 4, 2. I kind of need to fix my graph here. It looked like it was lying more at 4, 3. Okay. If I first reflect it over the y-axis, then that's going to reflect, it's going to flip from positive 4 to negative 4 for its x value. So the y value is still going to be at 2. And then from there, shift down 1. So it's going to land at negative 4, positive 1. And so here are the 3 points once they were transformed. Then you just try to do your best to draw that same basic shape, but going through those transformed points. And so this graph right here is the graph of y equals negative 1 plus the square root of negative x. The overall goal with these problems is for you to be able to look at a function like this and have a good general idea of what the graph looks like. And the way you would do that is because you would know, okay, square root, I know, I can picture in my head the graph basically looks like this. The negative in front of that x, so under the radical, is going to flip it horizontally. So it's going to take this graph in black, reflect it this way, and then that negative 1 will shift it down 1. So the hope is by the time you practice these a whole lot, you'll be able to look at an equation like this and kind of visualize, okay, so the graph would be the square root function, flipped over the y-axis down 1, so something roughly in the shape of this graph in green that I've drawn here. But so this graph would be your final answer to this question.